Higher order functions are functions that meet one of the two conditions. The first condition is using other functions as argument values. The second condition is returning a function as the output value. For each, map, filter, and even set timeout are all higher order functions as they all take a callback as their argument value. The closure program we created before is also a higher order function because it returns a function at the end. Next, let's take a look at the application of higher order function, currying. Currying means converting a multi-argument function into a series of nested single-argument functions. Currying was originally invented by Russian mathematician Moses Schonfinkel, but is named after Haskell Curry because he further developed and perfected the concept. We have a function here, add. It has two arguments, a and b. The add function will first validate the value of a and b. Then it will add a and b and output the total. Let's run the add function twice. In the first invocation, we pass 1 and 2 to it. In the second one, we pass 1 and 3 to it. Have you found any flaws with this program? The first argument value of the two invocations are the same, but the two invocations are independent, which means the same argument value will be validated twice. This is duplicated computing. If we can avoid it, we can significantly improve the program efficiency. Currying can help us avoid duplicated computing. We define a new function, curry add. It only has one argument, a. Inside the function, we validate the value of a. Then we return a child function. The child function also only has one argument, b. Inside the child function, we validate the value of b. Then we add a and b together and output the result. Now let's try the program. First, we pass the value of a to the curry add function. Then we store the returned child function into a variable. Next, we pass the second argument value to the returned child function. We can see the result is the same as before, but the validation of first argument value can be reused. If we do not reset the value of the first argument, it won't be validated again. Apart from avoiding duplicated computing, currying also gives us more control over the program execution. It breaks a function into a series of nested child functions. We can easily control the invocation of each child function.